Alright, at the top of page 4 then, continuing in 10.1, we can use the Pythagorean theorem, which allows us to then use the square root property to solve it. But we're using the Pythagorean theorem so you can find the distance between 2 points. So let's say you had 2 points. We'll call the first one x1, y1, talking about 2 points on a graph here. And the second one we'll call x2, y2. And we're interested in finding the distance between the two. Well, one way of looking at that is to say, well, there is to get there, if you use, like walking around the block kind of idea, you would go this direction a certain amount. In fact, you'd be traveling from x1 to x2, so that distance would be x2 minus x1, the difference between the x coordinates. And you would then go up to meet that next point, and that distance would be the difference between the y coordinates, y2 minus y1. And then once you have drawn that, what you're looking at is a right triangle, where the distance d is equal to the hypotenuse. And your x squared minus x, or not x squared, sorry, x2 minus x1, your distance in your x's, that's equal to one of the legs of the right triangle. And your y2 minus y1 equals the other leg of the triangle. And so you can take your a squared plus b squared equals c squared, where c represents the distance between the 2 points. In this case d, so we'll use that as our distance. Our distance squared is going to be those 2 legs squared added together. Your a value squared plus your b value squared. In this case, our a value was x squared, or I'm sorry, I keep saying that, x2 minus x1, the difference between the x coordinates. And your b squared is the difference between the y coordinates, y2 minus y1. And then you're able to solve that in terms of solving for distance. We're going to take the plus or minus square root of both sides. So if I write that out and give myself a little bit of workspace, d squared is equal to x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Then I can take the plus or minus square root of both sides, because again, my goal here is to find out what d is, what is the distance. And it's squared, so I undo that by taking the plus or minus square root of both sides, and what I get is just plain old d, not plus or minus, because the minus doesn't make sense here. It just undoes what we've got here, d, and then I just take the positive square root because negative distance doesn't make sense. So it's the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So this is an example of a formula that you could memorize, the distance formula. D equals the square root of the difference of the x's squared plus the difference of the y coordinates squared. Or you could redraw this picture for yourself and recreate it using distance formula and square root property. Totally your choice between whether you want to memorize the distance formula or whether you want to use the square root property to recreate it for yourself come test time. So here is the instructions. Find the distance between each pair of points, simplify any radicals, and then if needed, round to 2 decimal places. So that was my abbreviation there, if needed, round to 2 decimal places. Okay, so it might help you to label these x1, y1, x2, y2. It doesn't matter which is the first point, which is the second point. Just be consistent. It also will help to write out your formula every time you use it. Say it too as you write it. You'll learn that 4 times faster. So distance equals big old square root, the difference of the x's, x2 minus x1, that squared, plus the distance of the y's, y2 minus y1 squared, and then plug in those pieces. So my distance is equal to, so my x2 is 6, My x1 is 1, my y2 is 2, my y1 is 5. So I'm left with distance equals big old square root. 6 minus 1 is 5, that's 5 squared, plus 2 minus 5 is negative 3 squared. Notice I include the negative in the square because it was the answer to this, and then the whole thing is squared. And that leaves me with the square root of 5 squared is 25, 3 squared is 9, so that's the square root of 34. Punch that into your calculator and round it to 2 decimal places. You've got 5.83. And that's the distance. It doesn't tell us the units, so we'll just leave it as 5.83 units. Not even sure the book includes that as the measurement, so they might just say 5.83, and that's fine in this case. Okay, look at number 58. What's different about this one? We still have the 2 points. We've got a negative involved, and we also have radicals involved, but it's not going to change how we do the problem. We're still going to utilize the distance formula here. So let's go again with x1, y1, x2, y2. Again, it doesn't matter. I could have called this first point x2, y2, and the second one x1, y1. Does not matter. Distance formula. Write it and say it. Every time you use it, you'll see it and hear it at the same time. You're learning it 4 times as fast. Big old square root. Difference of the x's, that's x2 minus x1, square that, plus difference of the y's, y2 minus y1, square that. Plug that in, or plug in the pieces. And I'm just going to write the shell of the formula again and then plug in my pieces here. So x2 is 2 radical 3 minus our x1. Notice I already put the minus in there. It forces me to make it minus a negative, so negative square root 3. Very important, don't forget those. The negative is part of that x1 value. The minus is always there as well for the formula, so it becomes 2 radical 3 plus radical 3. Over here, y2 is radical 6, and y1 is 4 radical 6. I kind of got that a little squished here, so I'll try to talk through it. So let's simplify that. Distance, big old square root. 2 radical 3 minus a negative is plus radical 3, so you have 2 of something plus 1 more of something. That gives you 3 radical 3, and we'll be squaring that. Plus radical 6 minus 4 radical 6, something minus 4 of that same something is going to be a negative 3 of those somethings, so it's negative 3 radical 6 squared. And now do the squared piece, so it's 3 times 3, which is 9. Radical 3 times radical 3 is 3, so the squared leaves you with 9 times 3, plus square negative 3, you get 9, square radical 6, you get 6, so it's 9 times 6. And that gives you a distance of radical 27 plus 54. And then that's radical 81, which is just plain 9. And hopefully all that showed up on the screen. Alright, we did it. So now's the chance, I'm going to adjust the camera here, and now's a chance for you to copy what you saw, rewind the video as needed, copy what you saw, talk it through with somebody. We're applying the square root property to right triangles to then find the distance between 2 points. And then we're applying that distance formula on those 2 problems. And then here's one for you to try. Notice there's a negative involved, so watch out for that. So try number 52, bring your questions to class, pause the video, and then check your answer. Okay, and when you come back for number 52 here, and I'm just noticing that I don't have it written out on mine, so I'm going to go ahead and work this out for you. So don't keep you waiting here. 5 minus 2 quantity squared plus 2 minus a negative 2 quantity squared. That's going to give you a 3 squared, which is 9. Let's go ahead and make it 9. 2 minus a negative 2, 2 plus 2, that's 4. 4 squared is 16. And that's going to give you a radical 25 or just 5. So you should end up with a 5 there. And then a little bit of a typo here. This should say, this should point you in the direction of the book page. So that got cut off there. See page, this would be on page 605 for this helpful reminder, and it's the distance formula. Okay, and then we will move on to the 4th page of the notes, or the 5th page of the notes, the last part of this section.